All right, welcome back. Now here's another example. In this example, we've got two different trigonometric functions in our equation. So what we have to do is we have to convert or transform this so that it's an equation that involves only one type of trigonometric function. So in this case here, I'm going to use, since I have a cosine here, I can't do anything with that. But I can do something with the sine. I can use the Pythagorean identity. So what I'm going to do is I'm going to substitute in for cosine, right? I want everything in terms of cosine then. So I'm going to write this as 2 times the quantity, what? It's going to be 1 minus cosine squared x plus 3 cosine x minus 3 is equal to 0. So now what I'm going to do is simplify things. So I'm going to distribute the 2, so that's going to give me 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. Now I'm going to combine like terms, right? So I've got a 2 here, minus 3 there. So this is going to become negative 2 cosine squared x plus 3 cosine x minus 1 is equal to 0. Now I've got everything in terms of cosine. Okay? Now, what I'm going to do is I'm going to multiply everything by negative 1. Why is that? Because I don't want the negative on the leading term. Okay? We don't want to have that leading term be negative. So I'm going to multiply everything by negative 1. It doesn't do anything over here, right? So if I multiply everything by negative 1, all the signs change. So I get 2 cosine squared x minus 3 cosine x plus 1 is equal to 0. Now I can go ahead and factor this, right? Notice that it's in quadratic form. So now I can, again, use the AC method and decompose the middle term, yada, yada, yada. So 2 times 1 is 2. What two factors of 2 are going to give me negative 3? Of course, that's going to be negative 1 and negative 2. So again, I'm going to decompose the middle term. So I'm going to write this as 2 cosine squared x minus 2 cosine x minus cosine x plus 1 equals 0. Now I'm going to factor by grouping. So this is going to give me what? It's going to give me 2 cosine x times the quantity of cosine x minus 1. And then what am I going to do here? I want a cosine minus 1, so I'm going to factor out a negative 1. So that's going to give me minus the quantity cosine x minus 1 is equal to 0. And then what am I going to do here? I'm going to factor again, right? So I've got a common term again. So now I'm going to factor out the cosine x minus 1. So I'm going to get cosine x minus 1, the quantity of that, times the quantity of 2 cosine x minus 1 is equal to 0. And now I can use the zero product principle. So that means that cosine x minus 1 is equal to 0, or 2 cosine x minus 1 is equal to 0, which means what? Cosine, let me do it down here. So that means what? Cosine x is equal to 1, or cosine x is equal to 1/2. Now, when is cosine x equal to 1? What angle, what cosine of what angle is equal to 1 when you're dealing with a again, oh, do they give us? No, they don't give us a restricted domain. But if we looked at the restricted domain, when is cosine equal to 1? Okay, it's only equal to 1 at pi over 2. Okay, so this implies that we have pi over 2. And when is cosine equal to a half? Cosine is equal to a half when the angle is 60 degrees. And so, it's positive only when? What? That implies, again, if we just think about 0 to 2 pi, that happens when x is what? Cosine is positive in the first and fourth quadrant. So this is going to be when pi is equal to, or excuse me, when x is equal to pi over 3 or 5 pi over 3. Okay? So that means if we're looking at the general solution, because they didn't give us a restricted domain, so that means that the solution set is going to be when x equals pi over 2 plus 2n pi. Okay? Oh, wait a minute. I'm not thinking right. Hold on a second. No. Cosine is equal to 1 when x is equal to 0. It starts off at 1. Sorry about that. I was thinking sine. Okay, so this is 0. So actually, this just is going to be 2n pi. There we go. That's the right answer. And then, these two are right, so then the other two answers is going to be x equals pi over 3 plus 2n pi. And then the final answer, or the third part of the answer is whenever x is equal to 5 pi over 3 plus 2n pi. And of course, that's when n is an integer, right? And that's it. That's the general solution. All right, cool. Have a great day.